With this video, we want to know how to use Python to create a normal distribution graph. That's a graph with a bell shape. So first, let's know what normal distribution is. Normal distribution is a continuous probability distribution that is symmetric around its mean, with the most values near the central peak. With this one, it means that with a normal distribution, the mean is equal to, this happens when the mean is equal to the mode and also equal to the median. So if this happens, the graph becomes a bell-shaped graph. In some cases, we can also have where a mean is greater than the median and is greater than the mode. This case is known as positively skewed or right skewed. In some cases too, we can have where the mean is less than the mode, less than the median, and less than the mode and less than the median. In this case, it's called negatively skewed. So with this video, our main focus is to know how to use Python to draw a normal distribution graph. So let's start by importing our packages. So we import pandas as pd. We import matplotlib .pyplot as plot. We import numpy as np. Then maybe we use seaborn, so we import seaborn as sns. Now with this, if we want to draw a mean distribution, we don't have any data to draw it, so we have to import a data, or we have to, with the help of numpy, we're going to make a random of 1000. So a random figures out of 1000. So a random figures, let's say 1 2 3 0 point something, 0.84, 0.5 to 1000. So with the random figures, let's name it x. So let's name it x. So x is equal to, so numpy np dot random. We want a random figure, but it should be normal because we are drawing a normal distribution curve, so it should be normal. So np dot random dot normal. So into bracket, we want it to be a size of 1000. A size of 1000. Size of 1000. Size of 1000. Now let's start by just, this one is a sample graph, so let's start by plotting a sample one. So let's make it with the help of seaborn. So sns, we can plot it. Let's plot this graph and let's check sns does this plot. So this plot helps, with this plot, it helps you to plot a bar chart. Then after that, it draws a line on the bar chart to identify whether maybe the bar chart is skewed, right skewed, left skewed, or normal or symmetric. Symmetric is also known as a normal distribution. So sns dot this plot. So we are plotting x, KDE. The KDE should be true. That's a line. The KDE should be true. Then RAC2 should be true. So this is how it looks like. This is how it looks like. So this is the bar chart. The this plot help us to plot a bar chart. Then the line, there's a line in it. So this line help us to know whether the bar chart is rightly skewed, left skewed, or symmetric. And per our graph, this looks like a symmetric, meaning it's normally distributed. This looks like a symmetric, meaning it's normally distributed. Let's try by just sns dot this plot. Let's try by just plotting S without using the KDE and let's see something. So this plot. So if you try plotting SNS.displot, it will only plot this without a line. But the moment you add the KDE is equal to true, let's make the KDE false and let's see something. KDE false, meaning there will be no line. So the KDE help us to draw the line around the bar chart. The KDE help us to draw the line around the bar chart to help us to know whether it is symmetric, rightly skewed or positively skewed. So let's bring it back to true. Okay, now we want to make it a shaded portion. We don't want any bar. We want to make it a shaded portion rather. So sns.kde plot. So what are you plotting? You are plotting the variable x, then shade is equal to true. So this shade, so in this case there is no bar, only it has been shaded. So the moment you say shade is equal to true, it shades this portion. So let's try making it false. You see the portion shaded will be gone. So false. There will be no shaded portion, it will be only the line. There will be no shaded portion, it will be only the line. So let's edit a bit. Let's give it a title. So plt dot title, and let's name it symmetric graph. Let's give it x and y label. So plt dot x label. Let's name the x label. Values there. plt dot y labels. Let's name the y labels frequency. There's no wider. Let's name it frequency. So this is how it looks like. That's how the graphs looks like. Okay, this brings us to the end of using Python to draw our normal distribution curve. Please like the video, subscribe and put on the notification bell. Thank you.